Okay, so today we're looking at definite integration. And we'll have seen this before in further maths, but just want to run through it again. A definite integral, we've seen this integral sign before and the dx before. So the integral and the dx. But where we have these little numbers or letters above and below, that's how we know that this is a definite integral. A and b are just numbers, they're constants, and we call them the limits of the definite integral. So A is your lower limit and B is your upper limit. And the huge difference between a definite integral and an indefinite one that we have been looking at is that when we have a definite integral, we don't end up with a plus c at the end. We always end up with a numeric answer. We don't get a plus c, an unknown term. And the reason behind that is because when we integrate, we do the integration as normal. So when we integrate, say, dy by dx, we get back to y. Or when we integrate f dashed of x, we get back to the original function. But by definition, when we put a definite integral in, what we do is we plug these limits in and then take them away. So if I integrate to get f of x between the limits of b and a, then to find my numerical answer, I plug in b into this, so I find f of b, or whatever this function is, when I put that value b in. And then I take away from that, I always take away from it, f of a. So I plug in a into this function and take it away. Now, if you think about it, if you were just to integrate f dash of x, we'd expect normally to get f of x plus c, plus some constant. But because we're taking away f of a from f of b, this always disappears. The constant always cancels out, and so we don't need to worry about it in our definite integration. One last thing, just in terms of notation here, guys. So the start of it, much the same. We've got our integrand and our dx at the end and our function in the middle that we're integrating. Our limits, sometimes you'll see it as x equals b and x equals a. Sometimes you'll see it as just a and b above those. However, once you have integrated, and only once you've integrated, we then put the function we've integrated into square brackets. And that for me notates that we have done the integration, but I still have to insert my limits. Okay, so when you've done your integration, put it into square brackets and then put your limits beside that. And then we fill in our limits. Okay. So let's have a wee look at a few of these. So first one, integrate 3x squared between the limits of 2 and 0. Or x is 2 and x is 0. So we know how to integrate 3x squared, so I'm going to integrate this immediately. X squared, we raise the power by 1 to get x cubed, and then we divide by the power. Well, 3 divided by 3 is just 1, so actually that's our answer, x cubed. And because I've done the integration, I've got squared brackets, and I put my limits just at the top right and bottom left of those squared brackets. So what do we do now? Well, we're going to plug this limit 2 in for x, and then we're going to take away whenever we plug 0 in for x. So that becomes, when I put 2 in, that's 2 cubed, and when I put 0 in, that's 0 cubed. And 2 cubed minus 0 cubed is just 8 minus 0, which is 8. Okay, and we have a numerical answer for this. Same sort of thing with this second term. We have a polynomial here, a screed of terms, list of terms, and we can just integrate them individually. So they're all integratable. They're in a form that I can integrate it. So 2x integrates, well, x integrates to get x squared, divide by the 2. 2 divided by 2 is 1, so it's just x squared. When I integrate 4, I get 4x. Now my limits this time are 5 and 3. So I've done the integration. I now need to plug my values of 5 in for x here and then 3 in for x here. So let's put 5 in first. 5 squared is 25 and 4 times 5 is 20. And we're going to take away from that whatever we get when we put 3 into this. So again, what's 3 squared and what's 4 times 3? Well, 3 squared is 9 and 4 times 3 is 12. So here we have 45, take away 21. And so our answer is 24. Okay. So again, things to watch out for. Here's our limits. This is what we're integrating. We only put squared brackets in once we've done the integration. Keep the limits, this time they're on the right hand side of the brackets, and then fill them in and subtract. Two more, and these are the last two. Same sort of thing here, and we've done integration like this in the last exercise we were doing. We looked at these. The first thing we have to do here is actually turn root x into x with an index form. So let's do that. And because I haven't integrated yet, we keep the integral sign. So this is 4x to the half dx. Okay, notice there's no squared brackets there because I haven't done any integration yet. But I can integrate it now. So x to the half integrates to get x to the 3 over 2. And when I divide by 3 over 2, it's the same as multiplying by 2/3. So 4 multiplied by 2/3 is just 8/3. And that's my integration done. I don't have to worry about the plus c because it's definite integrals. And so I can put squared brackets around it and put my indices, my limits there. So let's fill this in. When x is 9, this is 8/3 times 9 to the power of 3 over 2. And we're taking away from that 8/3 of 4 to the power of 3 over 2. Well, 9 to the power of 3 over 2, 9 to the power of, that's the square root of 9 is 3, and when we cube it, that's 27. So this is 8/3 times 27. And we're taking away from that 8/3 times, well, again, the square root of 4 is 2, and 2 cubed, 2 to the power of 3 is 8. So this is 8. So this works out then as 72 minus, 64 over 3. Which again, just put it into your calculator. We get 152 over 3. We have a numerical answer. There's no value of c. Same sort of thing for question 4. It looks like these are all things that we can integrate yet, but before we do, we need to get rid of the fraction. So I'm just going to divide each of these terms by x to the 4. So let's redo this. I still haven't integrated yet. I'm just changing what it looks like. So this becomes 3x to the minus 2. So x squared divided by x to the 4 is x to the minus 2. Minus 1x to the minus 4. And now we can integrate this. So I'm going to put my squared brackets in. So x to the minus 2, raise the power by 1, we get x to the minus 1. And divide by minus 1, well, 3 divided by minus 1 is minus 3. X to the power of minus 4, when I raise that to the power of 1, I get minus 3. And when I divide minus 1 by minus 3, I get plus 1 over 3. And again, our limits are there. And just to make this slightly easier, I'm going to put it back in a sort of fractional form. Again, x to the minus 1 is 1 over x. So this first term becomes minus 3 over x. And the second term is, well, x to the minus 3 is 1 over x cubed. So a third of that is 1 over 3 x cubed. 2 and minus 1. So now it's just a matter of plugging these values in. I'm going to plug 2 in for x here. And then we're going to take away whenever we put minus 1 in for x. So when we put 2 in for x, we get minus 3 over 2 plus 1 over, well, 2 cubed is 8 times 3 is 24. And we're taking away from that. When I put minus 1 into this, minus 3 divided by minus 1 is just 3. Minus 1 cubed is minus 1 times 3 is minus 3. So that's minus 1 over 3. And again, when we plug that all into our calculator, we get minus 33 over 8. A negative value, that's fine, but we don't have a value of c. It's a definite integral. Okay, and that's where we're going with these definite integrations. We want to make sure that, first of all, they're in a form that we can integrate it, just like we've been doing, no problem. Then once we've integrated this term, make sure it's in squared brackets and the limits are at the sides. And then it's just a matter of plugging in that first limit in for x, plugging in the second limit in for x, and subtracting the two answers.